All right, so one is G, which is a kite. All right, what's the code?
Oh, wait. 747.
No, she won't be here today. Okay, so number 1 is a kite. So a kite has no sides parallel. Number 2, we're going over the practice test from geometry. All right, number 2, only one pair of opposite sides are parallel. There should be... And? Nope. And isosceles trapezoid, right? Still technically a trapezoid.
I didn't put that one.
Mm-hmm. Yeah, anytime you need to, you're more than welcome to just get up and do it. All right, number 3. 2 pairs of opposite sides are parallel. A, B, C, D. Good job, Isaac. You know your alphabet. I hope so.
I don't.
Oh, I cannot do it backwards.
No, there ain't no way. I hate it. I'm not going to do it forward.
Dylan's going to get a good laugh out of this one, guys.
Oh, can you hear us?
Yeah, I'm recording it.
Oh.
All right. So, number 4, only one pair of opposite sides are congruent. F. Number 5.
I was just about to say women exercise, but Emma did it.
All right, number 5. 2 pairs of opposite sides are congruent.
A, B, C, D.
Yes, A, B, C, D.
I got D. Wait. I got G.
All right, so opposite sides, right? So like for a parallelogram, opposite sides would be this side, right? So that's also going to be true for a rectangle and a square and a rhombus.
Kite? Oh.
Nope, opposite sides are not congruent for a kite.
D.
I got it right.
D.
All right, I haven't even asked the next question yet.
D.
Number 6, all sides are congruent.
D.
C and D.
Oh,
C
I
and
got
D.
B, B. I got
Right, so all sides are congruent for a rhombus and a square
But isn't a rhombus like a parallelogram?
with 4 congruent sides.
We should use this one.
No.
We should just make it
You're gonna make it do it over Zoom. Watch us.
No, I don't want to Zoom with you guys
I cut my
tomorrow.
camera off. Wait, if we're doing it at home, we can't use this, right?
I mean, yeah, I'm
Be
taking...
like, no.
No.
No, you guys cannot.
So we can
Or
use it.
get
All right. Number 7, all angles are congruent. No, we didn't. We did number 6,
B.
B and D.
Yeah. Boo! Oh, see, I'm taking it right. I was just on the wrong one.
Okay, number 8, only one pair of opposite angles are congruent.
G.
That is G.
Wow.
Right, so that's a kite. Right, so here's a kite. So this angle is congruent to this one.
I'm so dumb.
Not even a K on there.
I know.
All right, number 9, the diagonals are congruent.
D.
And
B.
F.
B.
F. Did you say F?
Yes. So diagonals are congruent for a rectangle, a square, and an isosceles trapezoid. Why? All right, 10.
A, B, C, D.
Yes, the diagonals bisect each other. So that is A, B, C, and D. Number 11, the diagonals are perpendicular.
C, G. got
B.
C, D, B?
D and B.
B, C, D.
DB. I got DB.
C, D, G.
Oh, okay, I got that completely wrong.
I got one right.
I got it. Good job.
D. Same.
I missed
All right, and number 12, at least one diagonal bisects the opposite angles.
C, D.
C, D, and G again. Let's practice this. So, for a parallelogram, we're given the angle ACD, so that's this angle here, is 106. All right, we know that EBD, so that piece up at the top here, so from E to B to D, is 72. And we know that from B to A to E is 44. Can you guys see the green okay? Okay. So we need to find the measure of CAB.
So DC. Oh, wait, 106. Is it 37?
All right, so remember that this angle and this whole angle are going to add up to what? 180, right? So we have 180. So let's subtract 106, and then we'll also subtract 44. Because that's the big red angle. So like the red angle and like this one that I'm going to do in yellow have to add up to 180, right? But we're trying to find this piece here. That's hard to see. I can tell by the look on your face. Hold on. So this piece here is what we're trying to find. Does that make sense?
Yeah.
So the purple part.
30.
All right. Right, so that's going to make that piece 30.
What happened?
Yeah, so then I did that to get 74, and then subtracted the 44 to get 30. Oh, wait, I'm sorry, that's CAE.
Yeah.
Yeah.
I was very confused.
Sorry. Hold
Don't
on.
you add 44 plus 44 plus CA?
No, it doesn't bisect the angle. Not for a parallelogram. No, so 180 minus 106 is 74 is going to give us this one. That's where that came from.
I was a little confused.
So
I'm sorry, guys.
For a parallelogram, the two angles beside each other have to add up to 180.
Yes, so for a parallelogram, the consecutive angles are supplementary.
I wrote this in pen.
That's okay.
The angles across. I put 30 in the wrong spot. No. Scribble it out.
Just scribble it out.
You see where those two things?
Or come borrow some white out. And get out a pencil.
What else? 180?
All right, so like this. Okay, here, let me erase my colors here. So in a parallelogram, right? So we have this blue angle. So these two are congruent. And then the blue and the red add up to 180.
So if you have to find the two separate angles for the red one, do those have?
You would have to have, they're not equal to each other. You would have to like know one part and like subtract it from the whole angle. Right? Okay, so let's do, any more questions on the parallelogram right now? Okay, let's do the rectangle that's on this one. Sorry, we will go to the ones you guys have in a minute. Although I can't find my sheet with those, so I'm going to have to borrow somebody's to look at. Okay, so we have a rectangle, right? What do we know about rectangles?
That all four angles are congruent.
All four.
Things are congruent.
It's pretty much perfect.
No.
Except for
It has four right angles, right?
where
The diagonals bisect each other, so that means this and this and this and this are all congruent, right? And the diagonals are congruent. And we know that this here, so from F to J, so this green piece right here is 12. So that means the whole length across would be 24. Right? So that means like from here to here is 24. And then from H to G, which is our first question, would be 24. Right? Because remember, diagonals of a rectangle are congruent. All right, so what's the next one? 45. No, it's not. Sorry. No. Diagonals of a rectangle don't bisect each other. They don't bisect the angles. No.
I thought it was 92, but then
All right, so look. So from G. Oh, yeah. So G to I to J. No, it doesn't bisect the angle. The diagonal doesn't split that angle in half. No. The whole angle, this would be 90. So like GIH would be 90.
What was it, 60?
Nope.
75.
Nope. Wait, maybe. Hold on. HFJ. Yeah, it would be 75.
Boom!
Because look, all right, so let's start. Look, we have this. All right, we know that HFJ is 75. So that is this piece here.
How did you know that? Oh, I totally missed
We know that because it's given to us down here.
that.
So if that's 75, then the one on the other side over here would be 75.
Oh, yeah. Okay.
And then when we subtract from 90,
Oh, dang it.
right, so that's 75. So HIJ would be 90 minus 75.
15.
What?
15.
Oh, I thought you guys said 58. I was like, hold up. We're going to have to go back to some basic math here.
Please, instead of this.
No.
I would always go. Oh.
Yeah, 15.
Actually, I take this as long as
So that's this one. And FGI is how, what? FGI. 90. All right, so let's look at the rhombus, okay? Rhombus. Guys, let's go. All right, so for the rhombus, we are given that the measure of angle MKO is 29. So MKO, so this angle up here is 29 degrees. Okay, so since that one is 29 degrees, for a rhombus, the diagonals bisect the angles. So that means this is 29, and this is 29, and this is 29. All right, do we understand how I got that? I'm not really worried about this yet. I'm just trying to, it's easier sometimes, I think, to just find all the angles first. No, the other ones are not 29.
Okay.
Because remember, all the angles have to add up to 360.
Oh.
Right, but we can do 29 plus 29 to get 58, right? And then do 180 minus 58, which would give us this piece here, which is 122.
Oh, wait, okay, and you need to divide that in.
Right, so I did, so let's talk through that one more time. I added my 29s together to get 58. Then I did 180 minus 122. I did 180 minus 58 to get 122. All right, now you can divide that in half, right? Because this here is split into two equal pieces. So each of these individual pieces would have to be 61. And remember, also in a rhombus, these angles in the inside are 90-degree angles. So the other way you could have found that 61.
Didn't you say if it didn't,
That's how I found it. I did it.
Go ahead.
didn't you say if it didn't have the square thingamabob on it that it wasn't 90 degrees?
Right, but you have to know to put it there for a rhombus.
What is that green?
61.
What is that green? I can't see it that clear.
Is that better?
It's too neon. I just can't see it.
Is the purple better?
Yeah.
Okay. Especially on pictures of stuff, it's hard to know what colors are going to actually show up.
What time does class get out?
11:25.
Yeah.
All right, so remember, though, for a rhombus, the diagonals bisect each other, so that's a 90-degree angle. So you could have also done 180 minus 90 minus 29 to get this is 61 because these three angles in this triangle add up to 180.
Oh my goodness.
It was ghost. It was ghost. They come before you.
All right, so angle LON would be what?
90.
90. Right, because it's in the middle, right? So anything with O in the vertex, as the vertex in this case, would be 90.
What?
All right, number 2, or 20, whatever. So OKL is 29. KLN is 122. And MKL, 58. Good job, guys. Right, but do you understand it now?
I think so, yeah.
Okay.
I get confused between like what rules go with what shape.
Right, so that's why when you are solving that shape, open your page up to look at the rules for that shape. That will help. All right, so then let's do a square. Everybody go with the rhombus? Okay. Also, I am recording this and I'll have this video up on LMS. That way you guys can go back and watch it too for the explanations of stuff. You're welcome. All right, so for a square, what do we know about a square?
That all sides are equal. And then
And they're all right angles.
equals 90 in the middle.
Yep, and they're perpendicular.
There's lots of 90s.
There are lots of 90s, and all of these are equal.
Square's the easiest.
Yep.
Yeah, I like squares.
Yeah, so PTQ. So the angle in the middle is, 90. All right, so PRS, 90. TRS, 45.
Gosh, how did I get all these wrong? Except for one.
All right, so remember, guys, listen. So for a square, again, the diagonals are going to bisect this, so it's going to split that 90-degree angle in half. So that means each of these pieces for a square are always going to be 45. All right, so we have an isosceles trapezoid. All right, so for the isosceles trapezoid, we know that the base angles are congruent. So this angle, that angle, then the two at the bottom. All right, so we are given that VUX, so this bottom left angle is 42 degrees. So that means this angle is 42 degrees. Okay, and we don't need this for what we're doing. So we know that the red and navy blue angles have to add up to 180. So we can do 180 minus 42 to get 138 for each of our red angles. So angle UVW is 138 and UXW is 42. See, isosceles trapezoids are fun.
I like isosceles trapezoids better than the other.
Yeah, me too.
I just don't like
Oh,
Okay, and then let's do the kite. All right, so for a kite, let's remember some things. So the diagonals are perpendicular. Okay, also this one diagonal here, actually let's keep talking angles. And we know this big angle is congruent to this big angle. And we know that this little angle is congruent to this little angle. And this little angle is congruent to this little angle. So, now, the first angle we're looking for is DEC. So what is that? 90. All right, the next one is ACD.
55. I'm guessing what's wrong.
125.
I got 55.
I got 125. 62.
I got a blank.
I don't know why I got 55. Why did I get
All right, so let's think about it. So all four of the big angles I have to add up to what? No, 360, right? So at the top, we know we've got 35 and 35, right?
Yeah.
At the bottom, we have 20 and 20. So that is 110 degrees when we add all that together, right? So if you do 360 minus 110, that leaves us with 250 degrees
I was right.
that we can then split between our two congruent angles that we have left.
125.
Yes, so it is 125.
Ah,
How did I get 55?
Right, so each of those blue ones are 125.
Oh, I think we added 35. Because the top one is
What did you add? 35 and 20 minus about 1.
All right, so look, all four angles. So look, this plus this plus this plus this add up to 360, right? So I added my two purple angles to give me 70 and subtracted that. So that left me with 290. And then on the bottom, I'm going to subtract 40 from my angles at the bottom there, which leaves me with 250. Then I divided that in half because that's how many degrees we have left. And so these two angles are congruent, so they would have to each be 125.
Hey, could you also do 35 plus 20 and then subtract that from 180?
Yes, because you would have just done half the triangle. Yes, that also works very well. Oh, my shoe got caught on my desk. Okay, so then angle EAC is 35. We already determined that. And BCD.
75.
So you're going to do 90 plus 20, which is 110, and then do 180 minus 110 to get 70. Because we're looking at this triangle here, right? So we have a 90-degree angle here, a 20-degree angle down here, and we're trying to find this piece. All right, so this video will be on LMS, so please go back and watch it tonight, tomorrow. Please take your stuff home.